Okay, so Gemma 4 just went open source. Google says that it can run on your local mobile devices and you can actually start to do real stuff with it. But is it actually true? I was extremely curious to see the real capabilities of the local LLMs, especially Gemma 4 family, which is Gemma E4B, which is 4 billion parameters, and Gemma E2B, 2 billion parameters. And to figure out what you actually do with this model, I decided to build a very simple to-do list application, include Gemma 4 locally into this, and try to see real use cases, how we can actually try to improve user experience by leveraging these local LLMs in our mobile Android device. So today I'm actually going to show you three use cases that I come up with in to-do list application. You will see in real world how it actually works on such device as a Google Pixel 8, which is, I would say, probably one of the low-end devices that actually will support local LLMs. So you can get some kind of feeling about the latency, the numbers, and try to think how you can include it into your existing mobile product, and maybe where you can do some optimization, or you will understand that now the cloud solution is still only way for you to work with. So quick info about what is actually Gemma 4 is. First important thing is that I need to mention that it has Apache 2.0 license, which means that you actually own the model. You can safely run it locally on your device. You don't need to pay for any API usage and do not pay anything for the cloud usage. It runs completely local on your device, which is actually a huge benefit for us. The second one is, as I mentioned, because it has bigger and smaller models. A smaller model, which is A2B, actually Google says that we can run them on devices with extremely low memory capacity because it takes around 1.5 gigs of RAM, which is crazy to think about. It means that you don't need to actually think about only top-end devices like Galaxy S24 Ultra or something like this, but this is actually possible to do on very simple devices, like in this example Google Pixel 8. Also extremely huge thing that it has support of function calling and multimodal inputs, like you can send audio plus text plus vision, which is something that was not available before, and as well it has support of some agentic skills. All of these like functions and how you can leverage audio capabilities, this is exactly what I'm going to show you today a bit later. And also pretty important, these tools that we are trying to use, it works only for Android 14 and above. So if your user base and your target Android is lower than Android 14, as for now, this is still a limitation. So you need to think about this, whether you can integrate it into your product or you need to wait a bit for a while. Today, I don't want to dive too much about the how you can set up, because you can go on the Google website and find the sample Android application to see the exact details about how you can implement it. But to give you some picture, you basically need three things. You need AI Core Developer Preview. This is actually the tool that allows you to interact with the local large language model through the APIs provided by the system itself. You also need Google AI Edge SDK, actually one simple Gradle dependency, so you don't need to care about too much. You of course need to handle the model download flow. For example, Gemma 4 billion parameters, it weighs like 3.5 gigs, and 2 billion parameters weight is 2.5 gigs. So this of course will take some time for your users to download it. You obviously don't want to include it into your application bundle because the size of your application will be just huge, so you need to plan user experience around this. But once model is downloaded, even on this low-end device, the actually cold start of the model while it's loading into your memory, it's pretty fast. For me, it takes around 5 seconds to load into memory, so based on how you will wrap it for your user experience, it's actually pretty fast. Let's go to the demo app, and I'm going to show you exactly how it actually works, so you will see it. And yeah, please don't pay attention to user experience and UI. As I said, it's just built for a couple of hours, and the goal here is not to show you the UI and UX, but rather to show you the real capabilities and how it actually works in real life. So what we have here, as I said, is a simple to-do list application. So you can have some task. It has title, description, date and time. And of course, traditional way, you can input it manually and save all information that you need. But because we are talking about Gemma 4, what we're actually going to do is to use three different use cases that I'm going to show you. First one, it would be voice to task, then it will be voice to note and voice to contact. Let me show you. So I'm holding a plus button. So I need to not forget to pick up a letter next Tuesday at 12 p.m. This letter would be from my tax authority. So now you can see the real time, how much time it takes to process the audio. So let's see what it does. So now we can press confirm. So the date is correct, the time it chooses 3 p.m. Instead of 12 p.m. It's actually interesting to know whether it's a bug itself into the picker or just model didn't get it. So, but we can press save, and now as you can see, it's already saved. Important thing to mention here is that we don't use like traditional speech-to-text way as most of apps does today. So what I'm doing is I'm actually sending the real audio file to the Gemma 4, so it actually can parse this file by its own, and it's way more precise in terms of the speech recognition than if you would use speech to text. So this is one of the strengths of the local Gemma 4 model as well. Now let me try to show you another example. I need to buy milk, eggs, bread, butter for the weekend. So yeah, again, now as you can see, it understood the context and it sees that it's actually a task. As you can see, we have a title and we have a grocery list. So based on the context, model understands what type of output it needs to provide, which is pretty cool. And another third example that I'm going to show you. So I need to save a contact of the guy, his name Josh Doe, as far as I remember. And phone number is 555-1434-261. And he said that he lives in Lisboa, Portugal. So now I can press confirm. And as you can see, so it parsed the name and surname, Lisboa, Portugal. So what it actually does, it's not only parse the details that I mentioned, we're also able to run system events with it, as in this case. So it's actually a system picker of the Android UI that allows us to save new contact. And again, all of this runs completely locally on your device. So I think that it's pretty cool, especially considering that it's very early stages, and we will see how all of this develops. But I already can see a lot of ways how you can integrate it into your existing mobile application, especially if you already provided some kind of AI tools. You can think how you can optimize it. I'm going to create a video with the case studies that I have done. It's when I'm using a hybrid model of using the LLM cloud and on the local. So we can see, I will show you actually in the terms of cost, how much you can save by leveraging local LLMs, by combining different approach for different type of tasks, where you can something delegate to local models on device, something that you can still process on the cloud. But already you can start to see some meaningful savings by leveraging local LLMs. In terms of the speed, as you saw, it's not blazingly fast. I have some numbers here that I'm going to show you about the processing speed. For example, 20 seconds audio took around 60 seconds to process. But 2B model, which is 2 billion parameters on the same device, I had for 25 seconds audio. In general, in average, I'm spending like 20 seconds of processing in real time. Of course, on some devices like S23, 24 Ultra that has more powerful chipsets and more RAM and more fast RAM, you'll start to see numbers that's already like 2 times smaller. So it works way more faster than in current example. But that was the goal for me, to show you the almost the worst case scenario in terms of the using local LLM. Now, let me actually explain to you how it works under the hood. These models able to provide you JSON structured format that you actually describe into model to expect. So the way how it works, I'm sending the specific prompt that includes the context around what's the goal for the model, what's the main purpose of the application, and as well I'm sending the structured JSON format that I'm expecting model to respond to me. So when model handle my input, it returns me result only in this JSON format, and based on the data on this JSON format, I'm actually able to understand whether it's the node, whether it's a task or the contact. Because model runs locally, it needs to know the current data in time. Because if you will say something like remind me in 3 hours that I need to do something, it doesn't really know this. So this is where the creativity comes to. So now, for example, I'm sending the exact data time to the model itself. So when I'm saying like tomorrow or in a couple of hours, it's already have a context because it understands the current time, the time of the request, which is something that you need to think about in advance. But again, in general, it's pretty great. And of course, I talked about the cost saving, but if you're in some very privacy regulated industry like finances or healthcare, where it's extremely important for your data not leaving the device, this is also opens huge doors for you, because all of this processes locally and this type of data never leaves your device. So it's extremely important for these industries as well. It's something that's Google really pushing hard, and definitely we are going to see more and more examples and improvements and optimizations in a very close future, because I personally believe that we are slightly moving from the cloud compute to the local compute, and this is where the power will live and where the power will be in the future. So if you want to see this, my case study in video about how you can actually today starting to saving cost in terms of the cloud LLM usage by reducing the amount of tokens that you're burning on the cloud, subscribe to note these videos that I'm going to release very soon. And thanks for watching. I hope you learned something useful today, and see you in the next video.